Okay, so in this video, this is still the learning about limits and kind of what they mean. So in this one, we're going to draw a bunch of different graphs, one for each part that satisfies the properties that are given in each part. So in this one, we've got limit as x goes to -2 from the left and x goes to -2 from the right. And the function itself either goes to infinity or negative infinity. So here's our sketch. Oh yeah, it's black. So x and y axes. Oh, I need x going to -2, so let's do this. All right, so here's -1, -2. And when I'm approaching -2 from the left side, the value of the function has to go to infinity. So the function will do something like this on the left side of 2. And on the right side of 2, or -2, the function goes down to negative infinity. So we can determine just from those two limits that we get a vertical asymptote at x equals -2. Excuse me. In fact, we can even tell that just from one of the limits because either one forces there to be an asymptote, right? We can also say, instead of a vertical asymptote, that these limits tell us there's going to be an infinite discontinuity at x equals -2. Okay, let's take a look at B. Okay, so B says the limit as x goes to 3 of some function equals 4. So let's just deal with this first. So as x goes to 3, these are all first quadrant stuff. So as x goes to 3, 1, 2, 3, the y value goes to 4. So this, since there's no plus or minus next to 3, it means both. So if we interpreted this first as x goes to 3 from the left side, the value gets close to 4, then we know that the function comes in around 3 and is close to 4, just like that on the left. And if we interpret it now as from the right side, then we've got that going on. And it also says that the value of the function at 3 equals 5. So the actual function here equals 5 there. So this info right here tells us that, we've actually got a removable discontinuity at x equals 3. Remember, it's called removable even if the function's defined, just because if I filled it in, well, then it's not a discontinuity anymore. I've removed it and made it continuous there. So, okay. Whoa, that is not what I wanted to do. All right. So let's look at C. C is describing what happens as x gets really, really negative, small, and really, really big, positive. So let's take a look. So as x goes to negative infinity, so that means when x gets further and further to the left, the y values get close to 2. So way out here at negative infinity, the y values get close to 2. So way out here, it looks something like that. I don't know if it's coming from above or below, but we do know way out at negative infinity, we get close to 2. The other thing is, as we get bigger and bigger and bigger, so going to infinity, the y values go to infinity. So that's going to do something like this way out at the end. Right? And I don't know if it's going to do something like that or something like this or what, but we do know it goes way up to infinity way out here. Okay, so what does that tell us? That tells us that we have a horizontal asymptote. The first limit tells us we have a horizontal asymptote at y equals 2 on the left side of the graph. And it doesn't really tell us anything about the right side. We definitely don't have a horizontal asymptote on the right side. We might have some sort of curvilinear asymptote over there, or slant asymptote, but but all we know is no horizontal. Okay, let's do D. So let's take each limit by itself. Need 5. So let's say 5 is here. And here's 1, here's 2. So as I approach x values of 5 from the left side, the y value is close to 1. So that's going to tell us something like this. And then as I approach it from the right side, I get close to 2. That's what this says. And the value of the function at 5 is actually 2. So then I'd have to fill in this dot. Then that's what I have. That's my picture. And this tells us that no matter what, we've got to jump discontinuity there. At x equals 5. 10 over t. All right. E, let's look at this one. So I'm looking around 1, and I've got some y values that say 3 here. So as I get close to 1 in the x values, both from the right and the left, since there's no symbol next to it. So as I get close to 1, both from the right and the left, the y values are close to 3. So that means I've got that. And then the second part says f of 1 equals 3. So that actually fills in that dot right there. And what we can figure out now is that whatever happens elsewhere, I do know that the function is continuous at x equals 1, right? And I can even tell you the y value is 3 there. So all around 1, it connects up, and at 1, it fills in the little hole. Okay, so that's it. Hope that helps.